Module 3, Objective 6, be able to recall the steps of endochondral ossification and know which bones undergo this type of ossification. Ossification is bone formation, and calcification refers to the deposition of calcium salts within bone. And calcification is a process that occurs during bone formation. We have two main types of bone formation or ossification in the body. We have endochondral, which refers to ossification that begins inside of cartilage, so endo, en, and then chondral refers to cartilage. Endochondral ossification is the main type of ossification in the body. The other form of ossification is called intramembranous ossification. Ossification occurs early in life, and some bones continue to grow even up to the age of about 25. Endochondral ossification is how most bones form. It begins with a primary ossification center that develops inside the framework of hyaline cartilage. Eventually, those cartilaginous structures are eventually ossified and replaced by bone. There are 7 main steps to endochondral ossification. The first step is that we begin with this cartilaginous scaffold or framework, and the chondrocytes within the center of the diaphysis, remember the diaphysis is the shaft of any long bone, the chondrocytes within the center begin to enlarge. As they enlarge, the matrix surrounding the chondrocytes are reduced. In fact, they're reduced to pretty much small struts, and those struts begin to calcify. The enlarged chondrocytes die, and they simply disintegrate, and they leave these cavities where the lacunae were. Step 2, you get the attraction of vasculature, so blood vessels are going to grow around the edges of the cartilage, and the cells of the perichondrium, remember the perichondrium is that membrane that lines cartilage. The cells of the perichondrium are going to convert into osteoblasts, and the shaft of the cartilage then becomes completely ensheathed within a superficial layer of bone. So the diaphysis, you can see the bone right here, the layer of bone forming around the diaphysis as endochondral ossification begins. And the third step, the vasculature penetrates the cartilage and actually invade and branch within the middle of the diaphyseal region. Fibroblasts that migrate with the vasculature, they differentiate into osteoblasts, and you get the production of spongy bone within the diaphyseal region of the long bone. The spongy bone is located at that primary ossification center. We see that right here, the primary ossification center. And eventually, ossification is then going to spread along the shaft towards the ends of that cartilaginous model. In step 4, we get remodeling. Remodeling occurs as growth continues, and that remodeling is going to create a medullary cavity or a bone marrow cavity. The osseous tissue of the diaphyseal shafts become thicker, and the cartilage near the epiphyses is slowly replaced by the shafts of bone, and that's further, it's going to involve further growth in both increasing the length and diameter of the bone. In step 5, capillaries and osteoblasts penetrate and migrate into the epiphyses. So remember, the epiphyses are the ends of these long bones. You have one up there as well as one down here. And with the migration of those osteoblasts and capillaries into those regions, you get the setup of these secondary ossification centers. The epiphyses eventually become filled with a spongy type bone, and the metaphysis, which is a relatively narrow band of tissue separating the epiphyses from the diaphysis. The metaphysis is still present in its cartilaginous form. So right now we have the metaphyseal region, which has the epiphyseal cartilage. And on either side, you're going to have bone. You're going to have bone up here in the the epiphysis rather, as well as bone down here in the diaphysis region. On the shaft side of the metaphysis, the osteoblasts continue to invade the cartilage and replace it with bone. And new cartilage is produced at about the same rate on the epiphyseal side. At some point around puberty, the rate of the epiphyseal cartilage production starts to slow, while the rate of the osteoblast activity speeds up. As a result, the epiphyseal cartilage gets narrower and narrower until it ultimately disappears. The disappearance of the epiphyseal cartilage is referred to as epiphyseal closure. So you actually get the epiphyses are going to fuse with the metaphysis, and the epiphyseal line is what's left. This, at one point, represented the epiphyseal cartilage prior to closure. But once you have closure, that bone can no longer elongate. Just a really crude drawing. If you consider the epiphysis of the bone, and then you have the shaft of the bone, or the diaphysis, it is right here in the middle between those two where you would expect the epiphyseal cartilage. And during growth, the epiphyseal cartilage is going to elongate the bone, and then it's going to be pretty much replaced by bone. And that series of bone elongation or cartilaginous growth followed by ossification of that cartilage continues, and it's a pretty steady state throughout prepubescent years. Once an individual reaches the age of puberty, the chondrification, or the development of that cartilage, starts to slow down. And as that slows down, the ossification also starts to speed up. And eventually, this band of cartilage, this epiphyseal cartilage, it gets thinner and thinner and thinner until literally the epiphysis is going to fuse with the diaphysis. And upon that fusion, all that's left is that epiphyseal line. So interstitial growth is the growth of length. Okay? It's also known as elongational growth. Elongational growth. Secondary ossification center develop. You get the closure of the epiphyseal plates, giving rise to the epiphyseal lines. And we can see, even in x-rays, here we have two x-rays of hands, and you can see that in the x-ray labeled A, we still have these regions. Let me use a different color here to sort of highlight that. We still have these regions of epiphyseal cartilages here in the phalanges, here in the metacarpals, even here in the radius. You have all these little arrows sort of indicate areas where the epiphyseal cartilage or these growth plates exist, and these bones are actively elongating. Again, they elongate through these activities, the chondrification followed by the ossification. And that process will continue until that epiphyseal cartilage band gets smaller and smaller and smaller until it ultimately fuses. And here in the x-ray on the right, we can see where these little white arrows indicate the actual fusion of the epiphyses to the diaphysis, and you get closure of that growth plate. And at that point, the bone can no longer elongate. Here's an image of a knee. I think it shows these various structures well. We have the growth plate right here on the tibia. We also have a growth plate on the fibula, and even up here on the femur, very nice growth plate. So at these growth plates are these epiphyseal cartilages, and cartilage is continually to be added, and as the cartilage enlarges, it is quickly ossified, and that process, again, of chondrification followed by ossification continues. At around puberty, this band of cartilage gets smaller and smaller and smaller until you get closure, where the epiphyses physically fuse with the diaphysis. And upon that closure, you get your epiphyseal line, which just basically represents where that cartilage once was. In addition to elongational growth, you also have oppositional growth, and this is growth in width. During oppositional growth, you get a thickening and strengthening of the long bones, and this involves layers of lamellae, referred to as circumferential lamellae, and we see that term right here. Circumferential lamellae get added to the superficial surface of the bone. During this process, osteoclasts are going to remove the bone matrix at the inner surface of bone, ultimately enlarging the medullary cavity. Here's a cross-section of compact bone. We see the spongy bone here in the medullary cavity region, and it's right here where we have these circumferential lamellae. So oppositional growth involves adding circumferential lamellae. So you end up adding these layers of bone surrounding the superficial layer of the bone itself. Other types of lamellae, we have the osteons, which are composed of concentric lamellae, right? Those, if you remember, your central canal is surrounded by these concentric lamellae, and we can see those represented here. In addition to this concentric lamellae of the osteon, we have the circumferential lamellae, which we've already identified as being important in oppositional growth. And what's left is the interstitial lamellae, and those are right here. And they sort of fill in the spaces between the osteons. So these little very irregular shaped patches of bone. And what these are basically old parts of osteons that have been partly dissolved by osteoclasts, and they simply fill in the spaces in between.